All right, in this video, we are going to introduce the idea of writing the equation of a line in space. Okay, so the goal of this problem is going to be to write the equation of the line through these 2 points, A and B. And this is an example in your book, but I'm going to start assuming that you know nothing. I'm going to start assuming you know algebra, but not how to do this in 3 dimensions. Okay, so as we get started, you'll think about if we're back in Algebra 1 and we want to write the equation of a line, what we have to do is we have to, y equals mx plus b would be one way to do that. B is your y-intercept, it's where you begin, and then the slope tells you, okay, well, I rise and I run and I do that sort of thing, and then that becomes the equation of my line in 2 dimensions. So in this case, what we're doing here is we're going to talk about if we're in 3 dimensions, so let me see if I can use this pen. Let's say the origin is anywhere. Okay, so here's the origin, and we want to write the equation of the line that my pen is traveling. Okay, so the first thing we have to do is you have to tell me where to begin. So you have to tell me, okay, if I'm at the origin, how do I get to the line? I need to somehow get to the line, and then I need to know how to travel up and down that line. Okay, so if you think about it, that's tell me where to begin, and then tell me how to travel up and down that line. So when it comes to 3 dimensions, we'll say that our x, y, z is equal to, well, we've got to get, okay, so let's say I've got a point A and a point B in space. Okay, the first thing I have to do is I have to get from my origin to point A or point B. So I can say this is vector OA. That gets me to my line, and then I have, I'm going to multiply a scalar times this vector AB. So what that will enable me to do, if I have vector AB that's starting at A, getting to B, if I multiply it by a scalar, then that enables me to go just a part of the way, or just or 1,000 times the way, and this will let me, if I can change this value right here, then I can travel up and down that entire line. So in a sense, this OA relates back to the y-intercept. X is your variable, t is your variable here. Notice I don't want to use x again because I've got x, y, and z. And then I have my vector AB. It's not the slope of the line, but it's the direction that the line is traveling. So slope and then that direction kind of go hand in hand. So what we'll look at here, we have these 2 points. So one of the things that let me say this. This is not the only way to write the equation of that line. I could say, well, that this x, y, z, or line 1 sometimes, or some might be how we say that, is equal to, well, it's OB. That got me to the line. Plus some variable. Sometimes they use lambda because it just makes us feel cool. And then I can do vector BA. So I've got different choices. I could do anything that's parallel to this AB. So I could do half of AB if I wanted to, or and sometimes if AB were something like 10, 20, 30, then I could just call this, instead of plugging in 10, 20, 30 times t, I could make it 1, 2, 3. So it just depends on the situation as to what we choose to do. But there's lots of different equations that we could begin with. Okay. So let's look at vector AB in this particular case. So -1 minus 2 is -3. Here's hoping I can do my arithmetic. 0 minus -1 is a positive 1. 2 minus 4 is -2. Okay, so one equation that I can come up with is that this line 1, x, y, z is equal to, well, I have to get to the line, so I can get to point A by going 2, -1, 4, plus t times -3, 1, -2, and this is what we call the vector form of the line, AB. Okay, I can also use this and put it into parametric form. Okay, so a parametric equation is an equation that has a certain parameter. And so typically we see what it's going to let us do is it's going to let us define our variables with a parameter, typically t or lambda or something of that nature. So x is equal to 2 minus 3t. And then the y value is equal to negative 1 plus 1t. And the z value is 4 minus 2t. And that is what we call the parametric form of line AB. Okay, and another thing that we can do with this is we can manipulate this to get to the Cartesian form or the rectangular form. And so what that will do, well, let me pause on the Cartesian for just a second. Let's say we're only in 2 dimensions. And let's say our x, y is equal to, I don't really care, 1, 2 plus negative 3, 4. I don't know, making something up. Okay, what I can do is I can say that was vector form. Here comes parametric form. What I can do is I can solve each one of these for t. So this becomes x minus 1 over a negative 3 is equal to t. Notice I subtracted 1 divided by negative 3. This one becomes y minus 2 over 4 is equal to t. Well, it's the same t in both of these situations, so I can set these equal. X minus 1 over negative 3 is equal to y minus 2 over 4. If I cross multiply, how do I want to? Okay, we'll say 4x minus 4 is equal to negative 3y plus 6. Here's hoping I remember my basic arithmetic. And then this becomes 4x plus 3y is equal to 10, and that's the standard form of the equation of a line. So this line that began, well, it passes through the point 1, 2. Its direction vector, I lied, its position, this is the position vector, and this is the direction vector. This tells us the direction that the line is traveling. This tells us a particular point on the vector. So we have to get to the vector, then travel up and down it. And we have to get to the line, and then travel up and down it. So this is from the origin to a point. That can also be written in the Cartesian form, 4x plus 3y equals 10. Okay, so we can also, and do you see this is something that you've done your whole life. If I solve for y is equal to negative, subtract that, 4 divided by 3x, and then plus 10 over 3. So here's your y-intercept, there's your slope. Notice the slope means I'm going to go down 4 to the right 3. So this is saying, so this was down 4, right 3, or it was up 4, left 3. And if you notice up here, this tells me to move 3 units in the x direction, the negative x, so that's left 3, which is what I had here, and then this is up 4. So that has this direction vector here corresponds with that slope. I digress. Okay. So coming back to this one, we had the vector form, we have the parametric form, and then we can take this and put it in the Cartesian form. So what we have to do for each one of these is solve for t. So the first one, t would equal, I'll subtract 2x minus 2 divided by negative 3. The next one, t would be equal to, well, I just have to add 1. There's nothing to divide. The next one, t would be equal to z minus 4 divided by negative 2. Well, all 3 of these are the same t, so the Cartesian form in this case this, ladies and gentlemen, looks a little funny, but this is the Cartesian form of the equation of line AB in 3 dimensions. If it makes you feel better, you could put that over 1, but you don't have to. It's entirely up to you. And that is the beginning of writing the equation of a line in space.